The world is gradually embracing renewable energy sources, and solar energy is a key player. However, high penetration of distributed PV sources cause undesirable effects to the grid, like phase imbalances, reduced power quality, etc. This project aims to mitigate some of such problems, while also making the final design open source. The main problems due to distributed generation like solar systems are harmonics due to power electronic switching devices, power factor variations caused because of improper active and reactive power generation, and safety issues during an islanding condition. In this project we tried to address these issues by developing an open-source solar inverter which consists of these grid-friendly features. First, let's explore the phase 1 of the project. This is the basic block diagram of a fully completed PV system. So first phase focuses on this filter designing section. An optimized LCL filter was designed in such a way that the best compromise between the filter performance and cost is achieved. Filter performance was measured using its harmonic rejection capabilities and also the stability of the filter. Cost functions was defined considering the energy losses, filter size and component costs as well. Designed filter was tested using both simulation and hardware setups. First PCB was mounted as shown here. Intelligent power module was used as the IGBT bridge. This is the completed setup for the final testing purposes. Here you can see how the unfiltered waveform has changed after going through the filter. THD value is well under the standard limits. Similar waveforms were obtained for the current as well. Then, let's explore the phase 2 of the project. In this phase our focus is on active and reactive power controller design for single-phase inverters. Active and reactive power control, which is simply known as PQ control, helps to perform optimal and smooth power exchange between inverter and the grid. A controller for single-phase inverter can be implemented based on DQ transformation. Power controller will regulate the actual inverter power outputs according to the references and generate the required current references for the inner current controller. After regulating the inverter currents, with the use of inverse DQ transformation, gate signals for the inverter can be generated. Finally, let's look at the phase 3 of the project, which is on islanding detection techniques and simulation. An unintentional islanding situation is a situation where the inverter operates continuously while the grid is disconnected. This poses a major security threat to the grid repair and maintenance personnel. Therefore, such a situation should be detected immediately. Islanding detection is carried out as presented here. First, the grid frequency is measured. Many methods can be used to measure grid frequency. We tried synchronous reference frame phase locked loop and zero crossing detection. Then the Sandia Frequency Shift method is applied. It looks for a frequency shift and applies it to a positive feedback loop. The output of the loop is compared with the over-frequency trip limits of the inverter. If there is an islanding situation, the feedback loop is continued until the over-frequency protection is activated. Else, the process is repeated.